Here we are, Geometry 7-2, Similar Polygons. And so I'd like you to copy all of this down, and then I'll take this away and we'll do some examples. But let me read it here. Polygons are similar. This should say are, not or. Yikes, glad I'm reading it. Polygons are similar if and only if their corresponding angles are congruent and their corresponding sides are proportional. So polygons are similar if and only if their corresponding angles are congruent and their corresponding sides are proportional. All right, if you're not done, pause and finish writing this down, and then we're going to do some examples. So here's your example of what we just said here. So here's an example of polygons that are similar. So similar just means that they're the same except for one is bigger than the other one. So if this quadrilateral here is A, B, C, D, and this one is W, X, Y, Z, the corresponding angles have to be congruent. So angle A has to be congruent to angle W. Angle B has to be congruent to angle X. Angle C has to be congruent to angle Y. And angle D has to be congruent to angle Z. Now the angles are congruent, but we also have to have the corresponding sides be proportional. So side AB over WX equals BC over XY. So I'm just saying AB over WX, BC over XY, CD over YZ, and DA over ZW. So the sides are all proportional. Let's do an example and see if we can use this, if that makes sense. I have a triangle that is triangle FGH, and it is similar to, notice this sign here for similar to, triangle JKL. List congruent angles and proportional sides. So we're going to do just what we did in this example, but we're going to do it with this triangle. Now, we're going to draw these two triangles, but you don't necessarily need to draw the triangles in order to be able to do this example here. But let's just draw two triangles, and we'll make them look kind of the same, except for one is bigger than the other one. And we'll say FGH, FGH, and JKL. Now, if it's helpful for you to draw the triangles, draw them. But you don't necessarily need to, because these congruency statements, or these similarity statements, I should say more accurately, will say that F and J are corresponding, G and K are corresponding, H and L are corresponding. So we can just say, just by looking at here, or if you need to draw the triangles, that's okay too. But we can look here and say angle, so I'm doing congruent angles here. Angle F is congruent to angle J. Angle G is congruent to angle K. Angle H is congruent to angle L. Now I need to do the proportional sides. So I'm going to say FG and JK, FG over JK equals GH over KL equals HF over LJ. And there you have it. Notice how on the top I've got all of the big triangles, the pieces of the big triangle, and the bottom I have the smaller triangle. And it doesn't matter which one is big or which one is small. All of the same triangles need to be on the top, or the pieces of the triangles, and then the other triangle, all of those pieces should be on the bottom. That's the important thing here. Not that one is bigger and one is smaller, just that one is all on the top and the other one is all on the bottom. That's the important part. All right, let's look at scale factor here. So a scale factor is the ratio of lengths, So we're going to do an example. I've got triangle ABC is similar to triangle XYZ. So I have a triangle here. There's triangle ABC, and AB is 6. Then I have another triangle over here, and this is triangle XYZ, and XY is 3. Okay, so now I need to look at these triangles because they're not oriented the way these other triangles were, how they're this, like this is the same as this one, it's just smaller. This one is the same as this one's just smaller. They're in the same orientation. This one are a little bit sideways. So I need to see, and they're also flipped. So I need to make sure I'm looking at the correct sides. So AB, notice AB is where I have this number, okay, AB, and XY is where I have the other number. And so I can see how AB and XY are both they're both in the same place in my similarity statement. So that means those are corresponding. So AB and XY are corresponding, so I know I can use these numbers to give me my ratio. So now what I do with a ratio is I take the second one and I put it on top, and that one is 3. And I take the first one and I put it on bottom. And that's my ratio, and then I need to simplify this ratio, so I divide the top and the bottom both by 3, and I get 1/2. So the ratio is 1/2. Notice how if I have this one's the bigger one, and I divide the whole thing by 2, I get this smaller one. Or I multiply it by 1/2, I get the smallest one. So I take the first shape, or the first polygon, I put it on the bottom. I take the second one, put it on the top. So the first one was 6, the second one is 3, and that's my scale factor, is 1/2. This one times 1/2, or divided by 2, is it gets me this one. All right, let's do another example. And this one is, which is similar to rectangle ABCD. So let's look at rectangle ABCD first. So BC is 8 inches and CD is 10 inches. Now we have two other rectangles here, and they both look like they might be similar to ABCD. This one is EFGH, and this one is JKLM. FG is 12 inches, HG is 14 inches, KL is 12 inches, and ML is 15 inches. So now we need to see which ones of these, which is similar So we're going to set up some equivalent proportions or fractions and see, we're going to see which ones actually are equivalent. So here's what we're going to do. We're going to take, now we can do this a couple different ways, but we'll try to keep it with what we've already been learning here. So we're going to say, we're going to set up these ratios. 8 over 12. Notice how we're using the same sides here. We're going to say 8 over 12 is equal to 10 over 14. And we're going to put a question mark here because we don't know if they're equivalent. You could also set this up as 8 over 10 equals 12 over 14. You can set it up that way as well. That's okay, but this is the way that we've already kind of introduced it. So this is the way we're gonna do it right now. Now, so notice how the corresponding parts are together. Corresponding parts are together. Okay. Now let's look at, let's set this one up as well. So I'm going to have 8 over 12 equals 10 over 15. And we'll put a question mark there because we're trying to find this out. Now, how do we decide if these are equivalent fractions? What I'm going to do here is I'm going to cross multiply and see what my answer is on both sides and see if it's equal. So 8 times 14. 8 times 14 is, what is 8 times 14? 112? Yeah. 112 equals 12 times 10, which is 120. So is 112 equal to 120? No. These are not similar. Let's check this one now. Again, we have 8 times 15, so that's 80, plus 40, that's 120, and then 10 times 12 is 120. Yes, these are congruent. So JKLM is congruent to ABCD. So I just cross multiplied, and I just saw if those expressions were the same on each side of the equal sign. All right, let's see if you try this one. I've got triangle ABC is similar to triangle RST. And I am going to draw them. ABC, and AB is 16. And then I've got RST, and RS is 4 and RT is 8. So I want to know what is the scale factor. For this U-try. And let's do that one and then we'll do the next one. I've got actually 3 total U-tries for you to do. So this is the first one and then we're going to have 2 more. Okay, go do this one. All right. Let's see. I have to decide here which parts are corresponding. And so I've got AB here, and I don't have any other numbers. So AB, that's the only measure I have. And so that means I need to find RS. And so look, here's RS, so that's 4. Okay, great. I'm going to ignore RT. That one was thrown in there just to mess me up. So I'm looking at the corresponding parts in this similarity statement. So now I put the first one underneath the second one. So 16 is going to go underneath 4. So my scale factor, divide each of these by 4, I get 1/4. My scale factor is 1/4. If I multiply this by 1/4, I get this one. All right, here's another U-try. Are these similar? All right, let's see what they are, Mr. B. Here is a triangle. This is triangle NQP. NQ is 12.5, QP is 11.5, and NP is 15. Let's do another triangle. We're going to see if these are similar. This is RST. RS is 10, ST is 9.2, and RT is 12. Now, here's some other information you need. N is congruent to R, and Q is congruent to S. Okay, so now you have this information, and you are now to find out whether or not these two triangles are congruent. Remember, if two angles are congruent in a triangle, then the third angle is also congruent, the third angle theorem. Okay, now your difficulty here is to find out which pieces are corresponding to one another, then set up a ratio, then see if they are proportional, or if these two are similar, if their sides are proportional. Okay, I've said enough. Get to work. Okay, let's see how you did. So I've got R and N are, angle R is congruent to angle N. And angle S is congruent to angle Q. So if I was to write a similarity statement, I would have, I'm going to start with this one on the left. So it would be NQP is congruent to triangle. So if I started with N, then I need to start with the one that's congruent to N, which is R. And then if I went to Q, then I need to find the one that's congruent to Q, which is S. And then I just have T left over. So writing this congruency similarity statement could be really helpful in making sure you set up your ratios correctly. Now, let's set up a ratio. So I'm going to do NQ and RS. So NQ is 12.5 and RS is 10. And I'm going to set that equal to, perhaps, QP over ST. So QP is 11.5 over ST, which is 9.2. Okay, now I'm going to multiply these. 10 times 11.5 is 115 equals 12.5 times 9.2. 12.5 times 9.2 equals 115. Yay, they are congruent. Yes. Now, you might have chosen different sides. So another congruent side would be, let's see, I did this one, 15 over 12. So NP and RT are congruent. So you could have said 15 over 12 equals 11.5 over 9. Or, any of these would have worked just fine. So this one you would have gotten 150 equals 150. But either way, these you should have found that they are similar triangles. All right, one more you try. I've got ACDF is similar to VWYZ. So these are two polygons, and they look kind of like trapezoids. And I got another one that looks like this. Okay. Now, this is ACDF, and this one is WVZY, like that direction. Okay. VWYZ. Okay, here we go. AF is 12, CD is 9, FD is X, YZ is 10, YW is 6, and ZW is 3Y minus 1. I want to know what X equals, and I want to know what Y equals. So pay attention to your congruency statement up here, and do some fancy proportion work and find out what x is, find out what y is. All right, go. Okay, let's see how you did on this last U try here. So FD is where x is. So FD is where x is, DF. And so that means I'm going to look at YZ to see what my corresponding number is here. So YZ is 10. Okay, so I'm going to say x over 10 equals, so x over 10. So now I want two numbers without a variable in them, or two values without a variable. So let's see if YW, that's right here, YW, well, maybe I'll circle it, YW or WY, and AF, uh-oh, YZ, WYZ, AB, oh, ACDF, yeah, I wrote that down, right? Okay, so WY and CD. Okay. So these are not drawn to scale. Okay, that's fine. Okay. YW is 6. And that's the one that's on the bottom. Remember, 10 is on the bottom, so 6 is going to be on the bottom. This is going to be on the bottom. This values are going to be on the top. And so CD is 9. Whew, glad we figured that out. Okay, so we're doing the corresponding sides over the corresponding sides. Now I just need to cross multiply. 9 times 10 is 90 equals 6 times x. Divide by 6. X equals 15. 90 divided by 6 is 15. So x is 15. Now I need to know what y is. So here is ZV. So that's 3y minus 1. And I'll put that one on the top. So ZV, that's these two. So now I need FA. FA is 12. So I'm going to put that over 12. And then I'm going to use this same 9 over 6. So, oh, I can't use 9 over 6. I've got to switch them because I put the smaller one on the top. 3y minus 1 is on the top. So that means I need the 6 to be on the top and 9 to be on the bottom. I just switched which shape was on the top and which shape was on the bottom. So for this one, x and 9 are on this shape, so they go on the top. And then 10 and 6 are on the bottom, they're that shape. Now on this one, I put the 3y on the top, so the 6 needs to be on the top as well. And then 12 and 9 are both on the bottom. Okay, so here we go. Let's multiply across and see what happens. 6 times 12 is 72. Equals 9 times 3y minus 1. 72 equals 9 times 3, which is 27, y minus 9. Add 9 to both sides. I get 79 equals 27y. Oh, wait a second. Did I do something weird here? Oh, gosh. 72 plus 9 is 81. Divide by 27. And then you get 81 divided by 27 is 3, so y equals 3. And that is your answer for that one, and that is the end of 7-2. Do the homework. Do a good job.